Good morning, Algebra 2. Mrs. Moore here. I have a quick little instructional video. That way today we can spend most of our class time practicing to make sure that you guys are understanding this concept. It can get a little bit tricky, especially with the algebraic pieces. So we thought that this would be a great idea for doing a little flipped classroom. You guys watch a video and then in class we can practice. So if you need to, pause your notes for a second and give yourself a good title here. I'm going to keep going. So in lesson 2.7, we are almost done with our linear function unit. And in our linear function unit, is a good time for us to start looking at what's called composition of functions. And in our last class period, we looked at the drug problem, which is where you had to find the connection between heart rate and time and amount of drug that was being processed in someone's system. So you had a drug depending on time, a heart rate depending on drug, and they were kind of all interwoven, and you ended up composing a new function out of two previous functions. So now we're going to get into some more general composition of functions. So to compose something means to take two things and make something new. So in this case, we're taking two functions. I've started us out with linear functions just to make it nice and easy. And we are going to compose something new. So the first thing, we're going to go through algebraic. We're going to look at tables, and then we're going to look at graphs. And I think that the algebraic piece is sometimes the trickiest piece. So what I'm going to do is we're going to look at something called evaluate. So these words actually do matter, and I never really knew it until I started teaching. So the first thing is going to be evaluating functions. So to evaluate means I need to actually get a number answer, a numeric answer from what I'm looking at. Wow, sunshine's coming in here. My little video area here at my house. Never a bad thing. Okay, so in this case, we're going to use our two given functions, f of x and g of x. And I would like to evaluate f of g of 0. Okay, so let's make a little bit of sense of this. So f of g of 0, this means we have a function within a function. So I've got g of 0 inside f function, which is a little bit crazy, but in terms of evaluating, it's not a difficult situation. I start on the inside. Always start on the inside and work your way out. So you can kind of just ignore this f part. If we were going to evaluate g of 0, this brings us back to like the first week of school. G of 0 means x is out, 0 is in. So x is out, 0 is in. So I'm going to evaluate 0 plus 1. So that's g of x is out, 0 is in, which means g of 0 is actually 1. So g of 0, input 0, output of 1. G of 0 is now 1. Bring that f down. We haven't done anything with f of x. All right, so we evaluated g of 0. The output of this evaluation becomes the input of our f of x. So now I'm just looking at f of x. Read your rule, f of 1. So x is out, 1 is in. So now I've got 3. Instead of 3 times x, I've got 3 times 1. And 3 times 1 is, of course, 3. So you've got to go through two different functions to get to where you need to be. G of 0 and then f of 1 in order to get to your 3. All right, let's try another one. So what if we were doing g of f of 3? G of f of 3. All right, this time, remember, start on the inside. So first, I can kind of ignore this g for the time being. Let's just find f of 3. 3, so I go into my function. 3 stays the same. X is out, new 3 is in. Well, 3 times 3 is just 9. Okay, so f of 3 is 9. But now I've got to keep going. Now I can incorporate that g of 9. All right, so now this tells you which function. Look, I'm going to switch functions. input of 9, 9 plus 1 is 10. And this is one of these situations. You want to do the whole thing in your head, go for it. I do not need to see any of this work. I was just trying to let you see what's going on here for composition of functions. So what we've just done is we've just put one function as the input inside another function. So for composition of functions, what we can do, and we usually use f of g, is we use f of g of x, where g of x is your input, or you could do g of f of x as your input. And sometimes if you're looking up some resources online, you might see a little f, teeny tiny little 0, kind of like a degree sign, but in the middle. So f of g of x or g of f of x. This means the same thing as the parentheses. I personally like the parentheses better because I can see that g is going to be the input, or that f is going to be the input. All right, so let's kick it up a notch. Let's say we're going to keep our same functions, but let's say now we're not going to evaluate. We're just going to simplify. So let's say we wanted to simplify. So here's our next piece. All right, let's say we just want to simplify f of g of x. Okay, so this time I don't have a numeric value for x. So what I'm going to have to do, this is where it gets a little crazy. What I'm going to have to do is I'm going to have to put this entire function, g of x, inside f of x. That's right. An entire function is going to be your input. All right, so I'm a big fan of circling here. So this entire function, I'm going to go way up here. So g of x is going to be the input into f of x. Where do you put the input in f of x? Oh, that's right. X is out. This entire function is going to be in. All right, so going back down to my problem, now I'm in f, so I've got 3. Remember, this x is out, gone. This entire function is your new input. Okay, so an entire function is my new input. Well, now we have to simplify. Okay, distribute, 3 talks to the x, I end up with 3x. 3 talks to the 1, I end up with 3. So f of g of x becomes a whole new function, 3x plus 3. All right, let's try the other way. What if I were to evaluate, what if I were to simplify g of f of x? You can see I wrote it in the new way. Doesn't matter. Everything stays the same. I'm going to add parentheses. I always do. All right, so this time f of x is going to go inside g. So f of x, this whole thing, 3x, goes tick, 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 tick. X is out. 3x is going to be in. So as I write my g of x is out, 3x is in, and then I still have my plus 1. Now on this one, is there anything to do? Nope, you're fully simplified. We're done. All right, so the algebraic pieces here can get a little tricky for sure. Okay, so next one I want to look at is tables. So what do we do with composition of functions that involve a table? Well, as you guys know, tables are my favorite because the math is there for you. You just have to find it. So looking at number 1 for a table, what if I wanted to find f of g of 2? So once again, I have a function in a function, which is going to make this a composition, one function composed of another. So just like early on, take a look at g of 2 first. All right, input of 2. Well, in my table, my inputs are always my x's. Sometimes I even like to highlight my x's. Okay, so if I'm going to input 2 into my g of x, input 2, output for g of x is going to be 1. So g of 2 is 1. Jump to my f. f of 1. Now you have to go back to your inputs. F of 1 is -2. So my final answer is -2. It's kind of like a little bit like a snake, going one from the other to the other. All right, let's try another one, number 2. What about g of f of 0? Okay, so f of 0. So you're looking for a 0. I see 2 of them, but remember 0 is on the inside. It's your input. If your input is 0, your output for your f function is -1. F of 0, -1. And now I need to find g of -1. Okay, input -1. Input -1. There is no input -1. So at this point, I'm going to say this is undefined. I don't know what -1 is. All right, last one. So we've got algebraic, we've got tables. I love tables. It's just a snake. Still can get confusing though. All right, and my last one is my graphing of my compositions. So I've switched functions a little bit here. I have f of x, which is 2x plus 3, g of x, which is -x. I thought this would be a good time to go over graphing again. So in order to graph this function, my y-intercept is up 3, and then I'm going to move up 2 over 1, up 2 over 1, up 2 over 1, filling up my graph. Because who knows where this composition is going to be. Again, the best part about videos is that you can always stop me. All right, so here's f of x. I'm going to label that. Now I'm going to do -x. My y-intercept is 0. I'm going down 1 over 1. Why down 1 over 1? Well, because it's negative. Negative slope. All right. So this one is g of x. Okay, sometimes I use colors, sometimes I don't so much. All right, so the first one I want to find using our graph is I would like to find f of g of 1. Okay, so same rules apply. Start on the inside. I'm going to find g, so my eyeball is going to the g of x function, input of 1. Well, this time, my inputs lie here on the x-axis. So I'm going to find an input of 1. There's my input of 1. And now I'm looking for my g function. There it is. So when my input is 1, my function lives down at -1. Okay. Now I'm going input of -1. So I need to go back to my x-axis. If I input a -1, which is right here, I'm looking for my f function. Here's -1, and that is going to be up 1. Okay, let's try one more. Okay, so one more. Let's try, I always like to switch it around. Let's try g of f of 0. Okay, input 0. So I'm going to my input. Sometimes, even if you highlight that inputs, kind of draw your eye back to the inputs every time. All right, if I input 0, so that's going to put me right here on the axis. I need to find my f function. So input 0, output is going to be right here, up at 3. Okay, so f of 0 is 3. Now I can ignore f of x. Gone. Now I'm just looking at g of 3. All right, back to my inputs. Input 3, input 3. Now I need to find g of x. Down there at -3. Input 3, output -3. All right, there we go. We got graphs of compositions. We've got tables with compositions. And my favorite, algebraic compositions. All right, thanks for listening. 15 minutes of your time. Today we are going to practice compositions in class. So, thanks for listening. See you soon. Bye.